Hello students, today's topic of discussion is classification of crystalline solids. Let's move forward now. So here the classification of crystalline solids is done on the basis of type of binding forces and type of constituent particles. Here the crystalline solids are classified into four categories: molecular solids, ionic solids, covalent solids, and metallic solids. Let's move forward. First, we'll have to understand about the molecular solids. Here, the constituent particles here in such solids are molecules, molecules of a substance, which are holding together to form a molecular solid. The molecules may be non-polar, that's dipole moment is zero, or maybe polar molecules, that's dipole moment is more than zero. So here the molecular solids are of three types: non-polar molecular solids, polar molecular solids, and hydrogen bonded molecular solids. So here in first non-polar molecular solids, the attractive forces operating between the molecules are van der Waals forces, or also called dispersion forces. The example is dry ice or iodine crystals. In polar molecular solids, the operating forces are just dipole-dipole interactions or dipole-dipole forces. The example is solid HCl or sulfur dioxide. And the third type of molecular solid is hydrogen bonded molecular solid. There, the, the molecules are held together by hydrogen bonding between them. The examples of such solids are hydrogen fluoride, solid ammonia, etc. If we go through this chart of comparison, here we can just summarize for non-polar. These are soft insulator of electricity, very low melting point. Intermolecular forces are London forces or dispersion forces. Examples are argon, carbon tetrachloride, hydrogen, and carbon dioxide. The polar molecular solids are soft insulator of electricity, low melting point. Intermolecular forces are dipole-dipole interactions, and examples are HCl and SO2. Hydrogen bonded molecular solids are hard insulator of electricity, low melting point. Intermolecular force is hydrogen bonding. In the example is ice, that is frozen water. So if you compare this chart, means if you compare the points of all these types of molecular solids, we find that hydrogen bonded molecular solid is the hardest solid, and all three kinds of molecular solids are insulator of electricity, and the melting point of non-polar molecular solid is the lowest one here. So let's move forward now. Next type of crystalline solid is ionic solid. Here the structure shown of NaCl, sodium chloride. Here what happens, the sodium ion and chloride ion, they are held together by electrostatic forces or ionic forces or ionic bond. So here every sodium ion is surrounded by six chloride ion, and vice versa. Means chloride ions also in turn surrounded by six sodium molecules. So the number of ions that surround a particular ion of opposite charge is called the coordination number. So here the coordination number becomes 6 because one sodium ion is surrounded by six chloride ions, and in turn the chloride ions are surrounded by six sodium ions. The other examples of such ionic solids are like cesium chloride, zinc sulfide, calcium chloride, or calcium fluoride, etc. Next category is covalent or network solid. Here you can see the picture is the arrangement of the carbon particles in diamond, and here the arrangement of carbon particles in graphite. These are the allotropic forms of carbon, and they form covalent bonds between them. That's why they form covalent bonds, and even they appear as a network. That's why these solids are called covalent or network solids. So the constituent particles here are atoms of the same or different elements connected by covalent bond. Here the most famous or important example of such kind of solids are like diamond. Like diamond is constituted by the carbon atoms, carbon tetrahedrons. Moreover to this carborundum, its formula is SiC, is also a covalent solid. And the other examples here are silicon carbide that is SiC only, and aluminum nitride that is ALN. Here the force which is holding together all the constituent atoms, that force is covalent bond, and they form to appear as a network. That's why these solids are also called network solids. The last category of the crystalline solid is metallic solids. Here is a small model what I tried to show you the picture of a metal in its metallic form, in its like rod-like structures. These positive charge, uh, the structures are called kernels, and these are the electrons out of these. So these are seems to be floating floating in a sea of electrons. Kernels are seeming to flow in a sea of free electrons here in the structure. So it's a model of a metallic solid actually. So here what happens, the bond between the the bond which held together all these atoms are the attractive force between kernels and mobile electrons are called metallic bond, which is holding together all these atoms in a metallic structure or metallic object. Here in metallic crystals, the metal atoms occupy the fixed position, but their valence electrons are mobile. The examples are of all the metals like copper, iron, nickel, silver. All these metals, they are having free electrons in them, and these are very good conductor of heat and electricity. So let's move and let's compare the all kind of the solids on the basis of different properties. First, we'll see the molecular solids. These are of non-polar, polar, and hydrogen bonded. The molecules are the constituent particles here. The attractive forces in case of non-polar molecular solids are dispersion or London forces, but in polar molecular solids, dipole-dipole interactions, and in hydrogen bonded molecular solids, the attractive force is hydrogen bonding. Examples here in non-polar molecular solids are argon carbon tetrachloride, hydrogen iodine carbon dioxide. In polar covalent solids are HCl and SO2. In hydrogen bonded molecular solids, the examples are H2O, that is ice. Molecular solids are generally soft, but hydrogen bonded solids are hard. These all are insulators and they are having low melting point. And among all these three kinds of molecular solids, the non-polar molecular solids are having lowest melting point. Ionic solids, the constituent particles are ions. The force is attractive force is Coulombic or electrostatic force. The examples are NaCl, sodium chloride, magnesium oxide, that is zinc sulfide, calcium fluoride, etc. Physical nature, that is hard and brittle, and they are insulator generally in solid state, but they are conductor of heat and electricity in molten state and in aqueous solution. The melting points are high. Here, the metallic solids, the constituent particles in metallic solids are positive ions in a sea of delocalized electrons. The bonding is metallic bonding. Examples like iron, copper, silver, magnesium. They are hard but malleable and ductile if we see the physical nature. And if we go through the electrical conductivity of such metallic solids, then these are good conductors of heat and electricity in solid state as well as in molten state, and their melting point are fairly high. The last category of the crystalline solids summarized as covalent solids or network solids. The constituent particles are atom forces. Attractive forces are covalent bonding. Examples are SiO2, that is quartz, SiC, carbonendum, carbon in the form of diamond, Al(N), aluminum nitride, and then carbon as graphite. So generally these are hard, but exceptionally graphite is soft. Generally covalent solids are insulator to the current or electricity, but exceptionally carbon is a good conductor of heat and electricity, and their melting points are very high among all these kinds of crystalline solids. I hope you are understanding well and you have understood the all categories of the crystalline solids well. So this is the assessment here, what I have taught you so far. Out of that, you can try these questions and you can assess yourself on the basis of these questions. Thank you very much for this class. Thank you.